Hello everyone. Today I bring to you another concept, and the concept is on slope. So it is on the concept of slope, classification of slope, process, and the evolution of slope. Now, as you are seeing in this cover page, two different types of slopes have been given. So if you see, actually, if you just look around you, slopes are actually the vital parts of our landscapes. Another important thing is that whether it is a plain land, whether it is a hilly land, whatever it is, the land surface of the earth is actually made up of slopes. It can be steep slope, it can be gentle slope, etc. So over here in this first picture that you are seeing, this is a hilly area. So you see the slope is quite steep, but this is an undulating plain land. So even the plain lands, for example, the Great Plains of America, etc., they are also not flat. So just like this is an undulating topography, they will have a series of gentle slopes and valley floors, etc. So what is basically slope that we have to understand? See over here, this land surface, this is sloping down. So if you make the earth's surface as an imaginary line, if you just draw an imaginary line over here, then the slope will refer to the angle. If this is the imaginary line of the earth surface, then the angle that this elevated land is making with that particular imaginary line is called the slope. Now over here, the slope, the angle that is being made over here and the angle that is being made over here obviously is varying. So of course, one can easily understand that over here the angle is steep, the angle is more. So the more the angle, the more is steep the slope. The lesser the angle, the more it is a plain land. So slope is what? It is nothing but a measure of the change in elevation. Now it can be expressed, since we are calculating the angle, so it can be expressed as in percent or in degrees. There are various geomorphologists who have uh, actually defined slope, and we already have the works of with us with Wood, King, Penck, Horton, Davis, etc. So you can divide the earth or the various types of slopes into generally of four classifications you can make based upon the nature of the slope or the angle of the slope. That is a gentle slope, which is 4 to 9 degrees or 4 to 9%, that is lesser than 9%. Then we have moderate slopes, which is little bit more, that is 10 to 15%. Then we have steep slopes, where the angle is 16 to 30%. And then we have extremely steep slopes where the angle or the gradient is more than 31%. So 31 to 60%. Now in this we see the classification of slopes. Slopes can be classified as endogenetic slopes or exogenetic slopes based upon how they are formed. So endogenetic, I hope till by now all of you know what is endogenetic forces, because there has been various references of endogenetic word in geography or geomorphology or geology. So endogenetic means when the processes that makes the slope, the slope evolutionary processes originate within the earth. Endogenetic refers to all those processes which results in the formation of slope, and these processes should originate within the earth, like the various tectonic processes of folds, faults, rifts, rift valley, etc. So all these things, these various earth movements lead to the formation of all these things. And these earth movements are a result of tectonic activities of the earth. So these are all endogenetic activities. And then we have activities which works upon the earth's surface or the external processes. So what are the external processes? External processes are weathering, mass wasting, erosion, deposition, etc. So these processes do not occur within the earth's surface. These processes occurs outside the Earth's surface, upon the Earth's surface. And there are various agents, as you very well know, for weathering, mass wasting, erosion, deposition. There are various agents. So in various geographical locations, various types of, based upon these agents, various types of landforms, slopes can occur. Then we have the exogenetically, we can delineate, we can classify the exogenetically created slopes into two types. What are the types? Erosional or degradational slopes, and then we have the depositional or the aggradational slopes. Now, in erosion or deposition, they are formed by various actions of the wind, running water, waves, glaciers, etc. So, glaciers and running water, they produce numerous landforms in the valleys. Not only glaciers and running water. So, each of them, they have their own type of landform, own assemblage of landform. Over here, you are seeing the erosional feature of a dry region or an arid region. So this kind of feature was given by this kind of slope was given by King. So for details upon this King's slope idea, you can go through the King's slope idea video. Next, we have the deposition or aggradational slopes. So they are again not different types of any other agent. The same agents which are eroding, the same agents will be depositing. So depositional or aggradational slopes are formed by the same action of wind, running water or waves, not by the same action, but by the same agents of wind, running water, waves, glaciers, etc. So again, when each of them works, when each of them deposits, what do they deposit? Whatever has been eroded, now is the time for deposition. So whatever are deposited, so again, each of these agents, the wind or the running water or the waves or the glaciers, etc., while they are depositing, they will again have their own assemblage of landform. For example, over here you are seeing alluvial fans. So alluvial fans, then natural levees, these are produced by running water. Moraines are produced by glaciers, or the various wind products like sand dunes, etc. They are made by the action of the wind. So you see how the various, these are the examples of exogenetically created slopes. Now, let us come to the elements of slope. What are the various elements of slope? According to King and Wood, they basically they have divided slopes into various elements, and according to them, a standard slope profile will have 4 elements: convex, then comes a free face, then comes a rectilinear slope, and then the concave slope. So in a convex slope, this forms the uppermost part of the slope. In any slope, the uppermost part is a convex slope, or it is also known as a crest. Now, this particular area is covered by various weathered material, and this is a result of denudational or weathering. And from here, transportation occurs through soil creep. Generally, we find this convex slope, this is also called the crest or the summit slope. Generally, we find this in humid temperate region. And after this, we find the free face or the scarp face. So this is actually called free face. Why is this term free used? Because you are seeing over here, this is a steep wall type of a feature. So because of this steep slope, steep wall type of a feature, this region remains free of any debris. Obviously, because of gravitational pull, they will be depositing down. So this particular area remains free of any detritus or debris. So geomorphologists, they call this as free face. then these will accumulate where? In the towards the cliff of the or the base of that slope. Then we have the rectilinear slope. So this lies below the cliff or below the free face. So this is also known as the constant slope. Why constant? Because the angle remains constant. Again, this is a denudation form, and in certain cases, we find a very thin layer of certain detritus, etc. Or sometimes they are underlain by solid rock also. Either they will be underlain by solid rock, or there will be a thin veneer of detritus underneath that. Then we have the concave slope. Here is the concave slope that is at the base of that slope. That is the last of the slope element. Now, since they are formed at the bottom of the hill slope, so over this particular slope element, the various runwash, etc., they they flow through this area. So this is the region of slope wash or the runoff of the various streams, etc. So along with them, they bring the various deposited materials also. But then this is not a depositional feature. They do bring it, but at the same time, they also erode this because they are eroding, and while they erode, the finer materials they are deposited towards the far end. So because of this erosion and deposition in the far end, so this results into this concave shape, and you see over here, there is a layer of debris, thick layer of debris underneath that. So over here, we have a thick layer of debris, which we do not have in the rest of the slope elements. Next, we have about the composite slope profile. Now, as I spoke before this slide, that there are, according to King and Wood, there are 4 elements of slope. But it is not necessary that all of them will be present in every type of region or every type of climatic conditions. One or more than one element may be missing from the slope profile because of various reasons. And what do we have in place of that? So we have certain composite profiles. Let us see some of them. So the first one is known as the convexo-rectilinear concave slope. So over here in this convexo-rectilinear concave slope, you see over here there is a convex summit. The summit is convex, as is generally as I have said previously. Then the summit is generally always convex. So we have a convex summit, and then we have a rectilinear or a straight slope, and then we have a basal concavity, a concave form. So all these parts, they are smoothly grading into, and you see over here, a curving slope profile is being made. So this kind of slope profile is more common where for the regions with weak rock types. Then we have composite profile with alternate bands. What kind of alternate bands? So you are seeing over here, alternate bands are here. So in regions where there are alternate bands of what? Alternate bands of massive rocks or thinly bedded rocks. So there might be massive rocks or thinly bedded rocks. So in that region where we have alternate bands of rocks, that is, we have heterogeneity in the nature of the bed surface. So in those regions, we find composite profile. And here, generally, these types of composite profiles are found where the relief is high and the valley floors, as you are seeing, they are very deep. And weathering in this type of region is very active. So in that kind of region, where all these factors are fulfilling, we have a composite profile. So this kind of profile, as you are seeing over here, they will have a number of, so there is a convex summit, That is one. And then we have a number of rectilinear, then free face. Again rectilinear, again free face. So the steep free face, and then we have a rectilinear slope. Again a steep free face, and again a rectilinear slope. And of course, the summit will be one only, and that is a convex summit. And the basal concavity will be very limited. Over here, we have a very extended basal concavity. But here, the basal concavity is very limited, or it may be absent. Then next on, we have the composite profile. So in a composite profile, what happens in this kind of a composite profile? So in a composite profile, what we see, this is found in arid regions with hard crystalline rocks. So in this type of a profile, we have a free face on the upper section. In the rectilinear section, we have a boulder controlled slope. Lots of boulders over here, or bigger rocks over here. And then we have a concave lower region, which is the pediment slope. So this is generally in arid regions. And if you have gone through my lecture on King's slope, then over there I have discussed about this type of slope, wherein I have mentioned that in King's slope also, that one or two types, that is a free face, maybe, or one or two types may be absent in one of the slopes. So over there I have discussed in detail about the nature of the pediment. So what are the reasons of the development of slope? We have seen different types of slope elements. So what are the reasons? So there can be various reasons. Foremost reason is rainwash and soil creep. They are the main agents, they are the main factors which leads to the development of a convex or the concave. So rainwash and soil creep, they regulates the convexity or the concavity. We had an American physiographer by the name of Feynman, and he explained that the most common convex or concave profiles, he explained that in terms of running water. So according to him, these upper slopes, they have less runoff during rainfall. And because for the obvious reason is these are the divide regions. So they have less runoff during rainfall. Also in this region, over here in the upper crustal region, we find that the interstream connectivity is less. So when the interstream connectivity is less, that means runoff will also be less. So water would move as thin sheet downstream. So when the water will move as a thin sheet downstream, slowly they will get loaded with the various particles. And as they move downstream, so there will be an increase of water. Why? Because more and more streams will be joining from the various subtributaries. The subsequent streams will be joining. So that means the runoff will increase. So the runoff increases. So the runoff increases as it moves down the stream. So there is greater erosion in the sections which are away from this convex. Again, I am saying this. In this, according to Feynman, over here in the crustal area, in the convex area, in the summit area, there is less runoff. Why there is less runoff in this region? There is less runoff during rainfall because the interstream connectivity is less. So because runoff is less, that runoff will slowly, whether it is more or less, it has to move down. But because the runoff amount is less, so it will move as thin sheet, not thick sheet. And when it moves down, what it will carry with it? The various materials, particles. As it moves down, the various other tributaries, sub-tributaries, etc., they will also join, the subsequent streams will also join the stream which has been coming from up. They will also join this. Now, when all this thing happens, so obviously the volume increases. So when the volume increases, the energy will increase, the energy of erosion will increase. Now when the energy of erosion increases, particle matters also increases. So what will it be its effect? That means there will be more erosion. That is why I told that there will be more erosion as one goes away from the convex crest. So as they are moving more downwards, that will cause more and more erosion will cause in what? A basal concavity over longer period of time. That will cause a basal concavity. And as more and more erosion, see over here, see the crest over here or the slope over here, the slope slowly it is getting more eroded. So it is receding backward. See how this is receding backward. It has receded backward. Earlier, the slope was like this, in this height. Now see, it is receding backward. It is moving backward. It is moving backward. It has moved backward. So because of this backward movement of an earlier uplifted, for example, earlier it was in this height over here. So earlier it was in this height, but now it has moved backward. This backward movement, because of erosion, leads to this shape. What is this shape? This is convex shape. Similarly, more and more inward erosion leads to what? This concave shape. So this is all about rainwash, erosion, and soil creep. Then Horton stated that on the upper section of the slope, erosion by wash is absent because again the same reason he gave, that is runoff lacks the required energy to erode. And further down, there is an increase in runoff, so sheet wash assumes more erosion. So there is more sheet wash because there is more volume of the volumetric water, the volume increases. With increase in volume, the various particle matters loaded in it also increases. So what happens? So there is the sheet wash becomes more important lower in the lower sections than in the upper sections of the slope. Now let us see the concept of slope form, process and evolution. Already I have spoken about this in some of my earlier lectures also. So what is slope form? Slope form refers to the slope elements which I have been saying in this particular lecture. What is slope evolution? It is a result of the action of the various process, slope forms changing in the courses of times, etc. So how a particular slope evolves. And what is the process? It refers to the various agents that are bringing about changes in the slope form. For example, for Davis, the process was what? Humid region, river action. So the process can be different for different people. So to know more about the process, you have to study about the various slope types given by Davis or King or Penck, etc. Now we have the various types of slopes which was given, or the evolution of slope. Like for example, the slope decline theory or the models of slope evolution. The slope decline theory was given by Davis in 1899. Then Penck studied about this slope decline, and then he came up with a more modified version. That is, actually, so Penck rejected Davis's slope decline theory or how slope is evolving, and he came up with a completely new idea, that is slope replacement theory, in 1924. Then comes L.C. King, who studied both Penck and Davis. He also studied about the works on wood, and then he came up with a modified version wherein he took certain concepts of both Davis and Penck and wood. He again rejected some of the concepts of Davis and Penck. So, by and large, he came up with his own concept in 1948. So, if we say about the slope process and evolution, so process refers to the agents that are bringing that change. So that may be the effect of rain, wind, glacier, sea, etc., sea waves. Evolution, this is the result of the action of the process. The ultimate action is the evolution, which I have shown in the previous slide. and slope form that changes in the courses of time. So it is not a static one. It changes, slowly changes, as we have seen in Davis, youth, maturity, old. Same we have seen in King, the various stages, youth, maturity, old. So a slope is not a static, it is dynamic. It will change with time. So this was all about slope, their classification, the definition, the process, and the evolution. So I'm sure that you could gain some knowledge from this. If you have any questions, you may write it down.